Today we'll be going through Cambridge International AS and A Level Mathematics Paper 3, Pure Mathematics 3, 970933, May-June 2020. Question number 1. Solve the inequality. So we will write this in non-modular form. So it will be 2x minus 1 squared. Both sides will be taking squared, and this will be greater than, will be basically excluding the negative term. So it will be 3 into x plus 2 whole squared. Both sides will be taking squared. Then 2x minus 1 squared is greater than 3 squared into x plus 2 squared, and we can open the square, which is 4x squared plus 1 plus 2, 4x. 2 into 2 will be 4, so this will be 4x. Basically this should be minus 4x, so this is minus 4x and is greater than 9, and this will be x squared plus 4 plus 4x. And now we can simplify this. We can shift everything to this side. Basically we can solve this one. After shifting to the other side, we can open this bracket. 4x squared minus 4x plus 1 is greater than 9x squared and plus 36x and plus 36. This is what we can do. Now we can form the equation. Basically we'll be sending everything to this side, so it will be 9x squared plus 36x and plus 36, and these will be shifted to other side. So minus 4x squared plus 4x minus 1 is this will be less than 0 because we are writing this one, so it will be this side. So this and this will be simplifying to 5x squared, and 36 plus 4 will be plus 40x, and this will be plus 35 is less than 0. And now we can solve the basically this quadratic equation by mode 5 3, and coefficient of x is equal to 5 and 40 coefficient of x, and 35 is the constant value, and this is minus 1 and minus 7. So minus 1 and minus 7, these are the two values which we found. And now we can basically we can write it as x plus 1 and x plus 7. So this will be the format, and x we can write is less than minus 1 and x is less than minus 7. Basically it should be greater than minus 7, so x will be greater than minus 7, and the inequality which we can write is x is greater than minus 7 and less than minus 1. This will be the answer for this one. We can understand this in the form of basically quadratic equation. We know this is a quadratic equation, so it is opening upward. Its graph will be opening upward like this one, so it will be symmetric like this. So it is opening upward, so we can take it as, like for example, minus 7 value and minus 1 value. These are basically the two values, so it will be in between this region. This will be the, so from quadratic equation also we can understand this inequality if you are not getting this one. So we can understand from here, this is one point and this is the second point, which we can understand from here as well. Hopefully you understood this question. Now question number 2. Find the exact value of this integral they have provided us to integrate. To integrate this one, we will be replacing 2 minus x. We can replace as 2 minus x is equal to u, and from here we can take the derivative. Du is equal to minus dx. So, and similarly we can replace, like for example, dv is equal to e raised to minus 2x, and we can integrate this and we will get v is equal to integral of this one will be same and divided by this derivative, so it will be minus 2, and this is how we got the integral. Then we will be replacing these values in this one, so we're getting integral of u, and this will be dv, u dv. So this will be basically u will be this one, u will be this portion, and d will be this portion. This one will be equal to what? This will be uv minus integral of v du, and we can integrate this from 0 to 2. If we replace the values 0 to 1, basically 0 to 1, and u is minus 2 minus x, and dv is our e raised to minus 2x dx. So this is what we have written in form of du and dv. So this will be integrated after, if we integrate the first portion, so it will be 2 minus x as it is, and integral of this one will be the same, e raised to minus 2x, and divided by its derivative, which is minus 2, this one, and integral will be from 0 to 1. From 0 to 1. Now minus this portion, minus integral of v, which is this one, so we can write e raised to the power minus 2x over minus 2 basically, and dx, this will be our value for this one. So this one will be minus dx, because du is equal to minus dx, so we'll be replacing here minus, we can put here, and this minus will be changing the sign, so we can write this one basically integral of 2 minus x into the same thing I'm copying, e raised by 2x over minus 2 and 0 to 1, and now this will be plus, this will be plus, and we can write this outside the integral, 1 by 2 integral of e raised to the power minus 2x dx. This will become our integral, and because of this one, this is minus 2, so this will become minus 2, because this minus and this minus will be plus, and this will become minus 2. And after that we'll have to just integrate and put the upper limit first. So if we replace the upper limit first, we can write it as minus 1 by 2, and this will be 2, and minus, first we will be replacing the upper limit, so 2 minus 1 into e raised to the power minus 2. This 2 we have written outside this one, and this is done. Now minus this portion, we will replace the upper limit first, so it will be 2 minus 0, so it will be also, this will be from basically upper limit will be 1 and lower limit will be 0, so it will be 2 minus 0 e raised to the power 0, and we can solve this one. So this will be 1 by 2 also outside over here, so we can take common, minus 1 by 2 we can take common, and inside will be basically, so we missed basically integral of this one, so when we integrate this, this will be plus 1 by plus 1 over 4, integral of this one will be 1 over 4 into e raised to the power minus 2x, and limit will be from 0 to 1, so this will be the complete integral of this. And after this one we will be just simplifying this step, minus 1 by 2. I'll move the page a little ahead, so this one we can write it as 1 minus 1 by 2. This will be, we can write this one as 1 over e 2 minus 2, and plus this will be 1 over 4 e raised to minus 2, and this will be minus e raised by 1, which is 1, so it will be e raised by 0 will be 1, so it will be 1 over here. And the final step which we'll be writing is 1 over minus 1 over 2e squared, and plus this into this will be 1, and plus 1 by 4 into this one will be 1 over 4 e squared, and this into this will be minus 1 over 4. And if after simplification, this into this plus this will be 3 by 4, so we can write 3 by 4, and this one we can simplify, this will be basically 2e square. So this 1 over 2e square plus 1 over 4e square will be minus 1 over 4e squared. So this will be our final answer for this question. Hopefully you understood this. Question number 3, show that the equation this is equal to 0 can be expressed as quadratic equation in e raised to x format. So we will be shifting this to the other side, so we'll get log of 1 plus e raised to minus x, and this is equal to minus 2x. Now we can remove this log or shift this log, so we can take base on both sides, or we will shift to this side, so it will be e raised to minus x, and when we will shift this side it will be equal to e raised to minus 2x, and this will be basically, now we can write this one, we can open this one. So if we open this, this will be 1 plus e raised to minus x, and this is equal to e raised to the power minus 2x, and now we can write this as a square format, so we can shift this to the other side. So e raised to the power x, e raised to minus 2x, and minus e raised to minus x, and minus 1 is equal to 0. Now we can put e raised to the power minus x is equal to u. So this will be u squared minus u, and minus 1 is equal to 0. This will be our quadratic equation. This is done. Now B part, hence solve the equation, this one, giving your answer correct to 3 decimal places. So we will be using the same quadratic equation, which is u square minus u minus 1 is equal to 0, and we can solve with mode 5 3, and this will be coefficient of x square is 1, coefficient of basically u square is 1, and coefficient of u is minus 1, and constant is also minus 1. So our value will be x u1 we can write as 1 plus under root 5 over 2, and the second value will be u2 we can write as 1 minus under root 5 over 2. These will be our two values, and we can write this one, for example, if we take the positive value, u value is basically e raised to the power minus x, so we can write e raised to the power minus x is equal to 1 plus under root 5 over 2, and this basically, to get rid of this e, we can shift it to the other side, and we can when we will be shifting it will be minus x is equal to log of or we can directly take log on both sides, and e will be cancelled, so it will be log of 1 plus under root 5 over 2, and this one x will be equal to minus log of 1 plus under root 5 over 2. If we calculate this, this will be mod 1, so minus log of this will be 1 plus, we can write here fraction 1 plus root of 5 and divided by 2, and this will be equal to minus 0.481. so this is equal to minus 0.481 and 2, but they are asking for 3 significant figures, so it will be 1, 2, 3 significant figures, so we can write answer as minus 0.481. We have basically solved this portion, but this is like the value which, if we will be replacing in this one, we'll be getting syntax error, which means that this is the negative value which we cannot take. We can check also, like for example here, if we just change the sign by minus, and we'll be getting syntax error, so negative value we will ignore. So ignoring the negative value, so we can write here. That's all. This is done. Now question number 4, the equation of the curve is provided, this one, and we have to find the derivative of it. So we will write this one the simpler way. Basically we can use for this one, this one is like x by 2, and we know that tan inverse, basically tan inverse of x is equal to basically derivative of this one, dy over dx of this one, basically derivative d over dx of this tan inverse x will be equal to 1 over 1 plus x squared. This is the formula which we'll be using over here, and this is u into v, basically product also, and for tan inverse we'll be using this one. So we can write dy over dx will be equal to derivative of x will be 1, and this one as it is, which is tan inverse of x by 2 as it is, and then plus x as it is, this one, and derivative of this. So derivative of this will be, we will write as 1 over 1 plus x over 2, and this will be squared, and derivative of this one will be 1 by 2, which we'll write over here. And now we can just write this as tan inverse of x by 2, and plus this one we can simplify. This will be x over this 2 into this one, we can write 1 plus x square over 4, and further simplification, basically this will be tan inverse of x by 2, and plus this one we can write x over 2 into this will be 4 plus x square, or we can write x square plus 4 and divided by 4, and this will be cancelled with this, and this will be 2, and this 2 will go up, and this will be equal to tan inverse of x by 2, and plus this will be 2x over x squared plus 4, and this one will be our final answer. Hopefully you understood each and everything. Now this is part B, the tangent to the curve. The tangent to the curve at point where x is equal to 2 meets the y-axis at point with coordinates OP, we have to find the value of P. So basically tangent of the curve equation we have already done in the previous part. We will utilize that one, and we will write dy over dx is equal to x over 2 is equal to basically tan inverse x over 2 plus 2x over x square plus 4. This is what we have done in part 1. Now just we have to replace x is equal to 2 in this one. So at x is equal to 2, this will be, we can write it as tan inverse of 1. This will be 2 by 2 will be 1, plus this will be 4 over this 2 square plus 4 will be 8. So this one, so we can write here tan inverse of 1 plus 1 by 2, and we can find tan inverse of 1 in radian mode. So it will be tan inverse of 1, and this will be equal to pi by 4. So our answer for this one we can write as pi by 4 plus 1 by 2. And now we can further simplify this, as we can take LCM basically. Okay, I'll take LCM over here, and we can take LCM this one 4, so it will be pi by 2, and this will be basically equal to dy over dx. Now the value of basically y we have to find for this one. This is basically the gradient, the slope which we found. This is m value, and we need the point, and for x value, x is equal to 2 or x value is equal to, we require y value, and for this y value we will be replacing this 2 in this one. If we replace 2 in this one, so it is basically x inverse tan of x by 2, so we can write it as x over 2 this one, and we can calculate this for x is equal to 2, and we will get pi by 2. So this is how we can find this one as pi by 2. This will be our y value. So this is basically the point, and for this point we can find, now we will use this point and this gradient, and we will write the equation. So we can use this space, so this will be y, equation of line in point slope format, y minus y1, when y1 is pi by 2, so pi by 2 is equal to y minus y1 is equal to m is pi plus 2 over 4 into x minus x1, so x minus x1 is 2. Now we'll have to simplify, and this one we can write y minus pi by 2 as it is, and this one no need to expand, just multiply this with this, like x plus 2 over, it will be expansion but it will be of a lesser level, so we can write it as, like for example, pi into x plus 2x over 4, and minus 2 into this one will be 2 pi by 4, basically plus 4 also. So this one, now further we can write y minus pi by 2 plus this is equal to this one as it is, pi x plus 2x over 4, and this one we can write minus, separate we can write denominator 4, so it will be 2 by 4 pi plus not plus, it will be minus, because we are, this one negative will be having impact on this, so it will change to minus, so it will be 4 by 4. Now we can basically write y minus, we can shift this pi by 2 to other side, so this is equal to pi x plus 2x by 4, and further we can write this one as minus pi by 4, minus pi by 2, because 2 2's are 4, and this one will be plus pi by 2, this one we have shifted to this, and this will be minus 1, so this will be cancelled, and our final equation will be y is equal to pi x plus 2x whole over 4 and minus 1. So in this equation, when they are saying when x is equal to 0 and value of p, so x is equal to 0 will be, this side will be 0, and y value is equal to minus 1, so p value will be minus 1 in that case. At x is equal to 0, y value will be equal to 0 minus 1, which is equal to minus 1, so p will be equal to minus 1. This will be our final answer for this question. Now here comes question number 5. By first expressing the equation, this one is equal to this as a quadratic equation in tan theta, solve the equation for this range, which is from theta from 0 to 90 degree. So we will be using two formulas in this question. One will be like tan of 2a is equal to 2 tan A over 1 minus tan square A. These are given formulas. So basically we need to reciprocate it. We need cot. So cot of 2 theta will be equal to 1 minus tan square theta over 2 tan theta. This will be the value for cot 2 theta. So, and this side we will be using another formula, which is basically tan of A plus B will be equal to tan of A plus tan of B divided by 1 minus tan of A tan of B. So this will be the formula which we will be using for this side, and this formula will be using for cot 2 theta. So our equation will become, basically this will be this side will be tan theta. So this one as it is, and we'll be applying on this. So tan theta as it is, tan theta, and for this one we can write it as tan theta plus tan 45 degrees and divided by 1 minus tan theta tan 45, and this one we have written by this formula. Now this is equal to this 2 into this one, 1 minus tan square theta over 2 tan theta, and this one we can draw a line over here. So this is basically the new shape. Now what we can do, this tan 45 basically, next what we can do, we can cancel this 2 with 2, and next thing, tan 45 is basically equal to 1. So our equation will reduce to this one as tan theta as it is, and this will be tan theta plus 1 over this will be 1 minus this will be tan theta, and this will be equal to 1 minus tan square theta over tan theta. So this will be our reduced equation. Now we'll multiply. This will be tan square theta plus tan theta divided by this will be 1 minus tan theta. Hopefully you are getting this. So this is equal to 1 minus tan square theta over tan theta, and now we can cross multiply. After cross multiplication, this will be tan cube theta, this into this, plus tan square theta is equal to this into this. We can write 1 minus 1 minus tan square theta minus tan theta and plus tan cube theta. So this one will be resulting to 4 terms, and this is cancelled with this. These are same. So everything we can shift to this side. So tan square theta plus tan square theta will be 2 tan square theta, and this one also will be plus tan theta, and minus 1 is equal to 0. Now this is basically our quadratic equation in form of tan theta. This is what they are asking for, quadratic equation in tan theta. Now solve the equation. For this range we have to solve this equation, and this is simpler. Basically we can use mode 5 3, and this will be coefficient of tan square is 2, so it will be 2, then coefficient of tan is 1, then minus 1, and this will be resulting to 1 by 2 and minus 1. So 1 by 2 and minus 1. So we'll be changing sign and writing here. It will be 2 into minus 2 tan theta minus 1 from here, from this one, and from this one we can write tan theta plus 1, because we will be changing sign and we will be writing here is equal to 0. Now this will be 2 tan theta is equal to 1 and tan theta is equal to minus 1. So this will be theta is equal to tan inverse of 1 by 2, and this will be resulting to, we can make line, so this will be theta is equal to tan inverse of minus 1. So we can check these values, mode 1. So this will be shift tan of 0.5, and this will be 26.6 degrees, rounded to 3 significant figures. If we check for this one, this will be minus 1. So for minus 1, this is resulting to minus 45. So minus 45 degrees. But as our range is from 0 to 90 degrees, so minus 45 is out of range, so we will write here no solutions for this part, and this part will be our final answer. Hopefully you understood this. This is extra page is done. Question number 6. By sketching a suitable pair of graphs, show that the equation, this one, has exactly one real root. To solve this question, we can have a suitable pair of graph. How will we getting that one? We can write, like, for example, x raised to power 5 is equal to y, and the other one we can write y is equal to 2x plus x plus 2 or 2 plus x or x plus 2. So this will be x plus 2. So this will be basically straight line, and this one will be the curve which will be drawing. And now we can take a rough basically coordinate axis to show this one. So we will be drawing like this one. I'm just drawing a rough sketch for your understanding, and this will be the coordinate axis and this will be the origin. Now we can roughly take, like, for example, here 1 2 3 4 5 6 7 8 9 and 10, and this will be the coordinate axis. And similarly from this side also 1 2, no need to take the scale, but just to be neat, I'm just drawing like this one. So similarly this side also we can draw like one. These will be the points like this one. So I'm taking half centimeter roughly. It's not accurate graph, just a sketch you will have to show like this. So this side also I'll be showing this one. So sufficient, I think so. Up to this one is sufficient. Now this is basically our coordinate axis. Now if first of all we will be drawing the straight line, y is equal to, so y intercept is 2, so this is 1 and 2 3 4, so it means it is passing through 2 point, and 2 point is basically this one. So a straight line is passing through this, and if y is equal to 0, x will be equal to minus 2. So minus 2 will be minus 1, this one, minus 2, this one. So it's passing through this. So we can sketch this line roughly, like, for example, this will be our straight line, which is y is equal to x plus 2. Now this is drawn. Now this one we can check when x is equal to 0. If we replace x is equal to 0, y will be 0. So this will be origin. So 1 point we have taken. Now we can take x is equal to, like, for example, 1. So y will also be 1. So x1, y1 will be this point. I don't know why I have drawn this. So So this will be the point. X is equal to 1, y will be 1. If x is equal to minus 1, y will also be minus 1. So minus 1 will be this point. And if x is equal to 2, y will be 2 raised to the power 5. So 2 raised to the power 5 will be equal to 32. So 32 will be huge number, so it will be going up. For 2 it will be going up like this one. So we can show this side, and it will be like this one. And if it is like, for example, minus 2, so it will be equal to minus 32. So for 2 it will be moving down like this one. So our graph will be this, and clearly this is basically only one point of intersection, and we can write this one that only one point of intersection. We can name it like, for example, P. So P is the only real root. B part, show that if a sequence of values given by iterative formula, this one x n plus 1 is equal to this one, converges, then it converges to the root of equation in part A. So for B part, we will be iterating this formula, like for example, x is equal to 4 x raised to 5 plus 2 over, this will be 5x raised to 4 minus 1, and we can cross multiply, or we can shift this to this side, so it will be x into 5x raised to 4 minus 1, which is equal to 4x raised to 5 plus 2, and we can open this one. This will be 5x raised to 5 minus x, and this one we can shift to this side, so minus 4x raised to 5 is equal to 2, and this will be x raised to 5, and x we can shift to this side is equal to 2 plus x, and we can see this is the same equation as given over here in part 1. So this is done. C part, use the iterative formula with initial value, this one, to calculate the root correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So the iterative formula provided in this B part, this one we will be using, and we will type this in calculator, and then we'll be finding the iterations. So this will be basically 4x raised to the power 4x raised to the power 5 and plus 2 over 5x raised to the 4 x raised to the power 4 and minus 1, so minus 1. This is our formula. So 4x raised to 5 plus 2 and 5x raised to 4 minus 1. So this is the formula which we'll be using, and they have told us to use this one. X1 is equal to 1.5. So our x1 will be equal to 1.5, and so we will feed this one, calculate for x is equal to 1.5. So our x2 value will be equal to this one, which is basically 1.3316, and they are saying up to 5 decimal places. So 1 2 3 4 and 6 1 will be 2. We can write here 2, rounded answer. And then calculate for x3, we can calculate for answer, and this will be equal to 1.27352, because this one also again up to 5 decimal places. And then calculate for answer again, and this will be giving us x4, and which is equal to 1.2672 and 6. and then we can write for x5. So for x5 we will be writing calculate for answer is equal to 1.267 1 and then 7, and then for x6 we can write again calculate for answer is equal to 1.2671 again 7. So we are getting two iterations same, so we will be writing basically. We can even check for further also if we want, but this is sufficient. So our x value will be equal to 1.267 up to 3 decimal places. So this will be our final answer for this question. And if you want, you can mention even this formula also, which we are using for iteration, which is equal to 4xn raised to 5 plus 2 over this is 5x and 4 minus 1. So this is the formula which we are using for this question. Question number 7. Let f of x is equal to this one. Express f of x in partial fractions. So this is simpler. For partial fractions, we can write this one as two parts, like for example a and b. So this is equal to a over this one 2x minus 1 and plus b over 2x plus 1. So this can be, and now we have to basically we can take we can multiply everything by this one, so by these two factors. So this side will be having 2 and this will be equal to, this will be cancelled, so only this one will be remaining, a into 2x plus 1 and plus b will be remaining, and into this will be cancelled and this one 2x minus 1 will be remaining. Now we can check for what value of b, for what value of x b will be 0. So that will be, you can even replace, like for example 2x minus 1 is equal to 0, so 2x is equal to 1, so x is equal to 1 by 2. So for x is equal to basically what we have done, if we replace 1 by 2, yes, we will be getting 0. So if we replace x is equal to 1 by 2, this b value will be 0. So we will replace x is equal to 1 by 2. So our equation will reduce to 2 is equal to a into, this will be 1 by 2, so it will be cancelled with 2, so it will be 1 plus 1 2, and this will be plus 0, so a will be equal to 1. And for x, for this one it will be like we can again replace 2x plus 1 is equal to 0, so x will be equal to minus 1 by 2. So now we'll be replacing x is equal to minus 1 by 2. So our a value will be 0, so b will be equal to minus basically 2. So 2 is equal to, this 2 is equal to b into minus 2, so b will be equal to minus 1. After getting this one, we can just write these values, like f of x will be, this f of x will be equal to a, which is 1, over this one 2x minus 1, which we have written over here, and minus b value, b value is minus 1, so we'll replace minus 1 over, this is minus 1 over 2x plus 1, and this one will be our final answer for this part. B part, using your answer to part A, we have to show this one. So f of x we know is equal to this, so f of x is equal to, we can write this one as 1 over, we can write like 2x minus 1 is equal to u, and we can write 2x plus 1 is equal to v. These values we can use over here. This will be 1 over u minus 1 over v, and if we take square on both sides, this side square will be equal to this side square, and open square, this will be f of x squared will be equal to, because we need square, so f of x squared will be equal to 1 over u squared plus 1 over v squared minus 2 into 1 over uv, we can write like this one, and this will be basically 1 over u square plus 1 over v square into this one. And now what we can do, we can replace the values, and replacing value will be 1 over u square, mean 1 over 2x minus 1, 1 over 2x minus 1 squared, and plus 1 over v will be 2x plus 1 squared. I will move the page a little above so that you can see properly, like this one, and minus 2 over u into v. U is this one, 2x minus 1, and v will be 2x plus 1. So this, and then we can basically for this section, this one, we have already done this partial fraction for this one, 2 over this. It's the same answer which we are getting, so we will be using this answer for part A, and we will write here 1 over 2x minus 1 squared plus 1 over 2x plus 1, this is minus 1, this is plus 1 squared, and for this one we will be using this, so it will be minus 1 over 2x minus 1, and this will be minus and minus will be plus, so it will be plus 1 over 2x plus 1. So this will be the partial fraction which we are using from the previous part, and this one we can write as our basically final answer. This is our final answer for this question. C part, hence show that integration of this square is equal to this one. So for this C part, basically we will be using the result of this B part, which is over here. We will be using this, and I will copy this one. So it will be integral of 1 to 2 and f of x square. So f of x square, which we can write it as 1 over basically 1 over 2x minus 1 squared, and minus in sequence we can write 2 over x minus 1, and plus this will be 1 over 2x plus 1, and plus this will be 1 over 2x plus 1 squared, and this will be basically, we can put in brackets, and this will be dx. So this will be this integral which we have to integrate. So we will be this one will be log x formula, and we can use this one, integrate, like for example we can integrate this one to like for example, first we will shift, basically first we will integrate from 1 to 2, we will shift this 2 up, so 2x minus 1 will be minus 2, and then minus this will be 1 over 2x minus 1 plus this one as it is 2x plus 1, and this will be plus this one we can move up, so 2x plus 1 raised to the power minus 2, and this will be basically dx. Now we start integrating, and our integration will be 2x minus 1 power will be reduced to minus 1 and divided by the derivative, which is and power also, so minus 1 into 2, and this is the integral. Then minus this one will be 1 by 2 log of 2x minus 1, and for this one similarly it will be 1 by 2 log of 2x plus 1, and for this one we can integrate as 2x plus 1, and power will be reduced by minus 1 and divided by, it will be minus 1 power and into derivative, which is 2, and integral will be from 0 to 1 to 2 basically. So it will be 1 to two integral values which we have written over here. Now we will be basically replacing the values for this one. If we replace the upper value, we can replace turn by turn upper value and then lower value. So we will replace upper limit 2 first, and if we replace directly in this one, we'll be getting 2 into 2 4, 4 minus 1 will be 3, 3 raised to the power minus 1 over minus 2, and for this one it will be minus 1 by 2 log of this will be 4 minus 1 will be 3, and in this one if we replace value it will be 1 by 2 log of 2 into 2 4, 4 plus 1 will be 5, so it will be log 5, and plus for this upper limit it will be 2 into 2 4, 4 plus 1 5, 5 raised to minus 1, 5 raised to minus 1 over minus 2, and this is basically the upper limit which we have replaced. Now the lower limit also we can replace in the same way, and if we replace the lower limit, I'm putting over here, and lower limit will be 1, so it will be 2 minus 1 will be 1, so 1 raised to the power minus 1, so we can write it as 1 over this one will be 2, so this will be 1 raised to minus 1 will be basically minus 1, so 2 minus 1 will be 1, so 1 raised to minus 1 will be 1 over 1, basically it will be 1, so this one we can write it as minus 2, and minus 1 by 2 log of 1 minus 1 will be 0, so basically I will write as it is, you will check with the calculator, so log of 1, then for this one also we can write plus 1 by 2 log of this one will be 2 plus 1 will be 3, so this will be log of 3, and we can replace in this also, so 2 plus 1 will be 3, 3 raised to the power minus 1 over minus 2. Now we can shift the minus power down, so it will be minus 1 over 6 for this one, and minus basically this will be 1 by 2, or we can write as it is, like for example 1 by 2 log 3 and plus 1 by 2 log 5, and then this one will be minus, this will be 1 over 10, so this will be our first term, and minus this one we can write minus 1 by 2, minus 1 by 2 this one, and minus 1 by 2 log 1, and plus 1 by 2 log 3, and this will be minus basically 1 by 6, so minus 1 over 6, and this will be done. Now we can calculate for this all, we can solve this in one go, and this will be basically we can write here, like we can open and minus 1 over 6, I'll move page a little above so that you can properly see this, so minus 1 over 6, and log values I will be writing separately, so we can 1 minus 1 over 6 and minus 1 over 10, and this one will be basically this one will be 1 by 2 minus 1 by 2, we can take common from here, so it will be log of 3 plus log of 5, so this one will be our first, and the second factor also we can write minus 1 by 2 and minus 1 by 6 and minus 1 by 2, we have taken minus 1 by 2 common, so this one should be minus, which we are doing mistake, so this should be minus, and here we can write it as minus 1 by 2 common, and inside will be log of 1, and minus log of 3, and this will be closed. Now this step basically we can simplify minus 1 over 6 minus 1 over minus 1 over 10. This will be equal to minus 4 over 15. So these two will be resulting to minus 4 over 15, and this one we can write separately minus 1 by 2 log of 3, and this will be plus 1 by 2 log of 5, and this portion we can keep as it is, and we will be simplifying this one. Minus 1 by 2 minus 1 over 2 and minus 1 over 6, and this will be equal to minus 2 by 3. So we can write here minus 2 over 3, and this will be minus 1 by 2. Log 1 is basically 0, so it will be log of 3. So we can write here this will be plus log of 3, this one. Now we can open the brackets. So this will be equal to minus 4 over 15, and this will be plus 2 by 3 plus 2 over 3, and minus 1 by 2 log 3, and this will be plus 1 by 2 log 5, and this will be minus 1 by 2 log 3. And now what we can do, we can simplify this one. Minus 4 over 15 plus 2 over 3, and this will be equal to 2 by 5. So this will be 2 over 5. This is done. Now this one we can write this plus 1 by 2 log 5, and this will combine to minus log of 3. And next step, what we can do, we can make it like to combine these two. We'll write this one 2 over 5 plus this one we can write 1 by 2 log 5 minus this we can write as log of 9 raised by 1 by 2, and this one we can write power first. So it will be 2 over 5 plus 1 by 2 log of 5 over 9, like log a minus log b will be equal to log a over log b, and this is the required basically format which they are asking for in the question, and hopefully you understood this. Now question number 8, relative to the origin O, the points A, B and D have position vectors given by O is this one, OB is this one, OD is equal to this one. A fourth point C is such that ABCD is a parallelogram. Find the position vector of C. Position vector of C we have to find and verify that the parallelogram is not a rhombus. So two things we'll have to do. One thing, we have to find the position vector of C, and the second thing, we have to prove that the parallelogram is not a rhombus. So to understand this one, we'll just draw a simple parallelogram like this one. So say this is the parallelogram, and we will be, just for your understanding, it's not required in question. So we can take, like for example, A, B, C and D points. So we know that coordinates of OA are this one, so we can write in column vector. OA vector will be equal to 1, 2 and 1. So this will be column vector for OA, and OB is equal to 2, 5, 2, 5 and 3, and OD also we can write. So OD is equal to 3i, and there is 0j and 2k. So this will be column vector of D. Now as we know, this is basically parallelogram, so AB will be equal to DC. So AB is equal to DC. So it's basically given that ABCD is a parallelogram. So now we can write this coordinates. How we can write this AB? We will be writing OB minus OA vector, and this will be equal to OC minus OD vector. This will be in vector format. After this one, we will just replace the values, and before replacing the values we can shift this OD to this side. So OB minus OA plus OD, these are all vectors, so is equal to OC vector. And now we will be replacing, we have OA, OB first, so it will be 2, 5 and 3, and minus OA, which is 1, 2 and 1, and plus OD will be 3, 0 and 2, and this is equal to OC vector. Now I'll move the page a little above here. Now we can simplify this. There will be 2 minus 1 plus 3, so we can write 2 minus 1 plus 3. Similarly 5 minus 2 and plus 0, and the last one will be 3 minus 1 and plus 2. This will be equal to OC vector, and this will be 5 minus 1 will be 4, and this will be 5 minus 2 will be 3, and this will be 5 minus 1 will be 4, and this will be equal to OC vector. And this one basically we can write it as 4i plus 3j plus 4k. So this is what we found, the basically the vector for this one, OC vector. So after finding this OC vector, we have to, this is OC vector. After OC vector, we have to verify that the parallelogram is not a rhombus. Now to prove that this is not rhombus, we will be using these diagonals, basically AC and BD we will be finding, and AC and BD, if we prove that they are not perpendicular, it means it will not be a rhombus. So to prove that they are not perpendicular, we will be proving that their dot product is not equal to 0. So AC vector and basically BD vector, we'll be finding these two vectors and proving that these two are not perpendicular to, they are not, their dot product is not equal to 0. So AC will be OC minus OA, this one, and ABD will be equal to OD minus OB vectors, and we have these values. Basically OC is provided, which is OC, basically we just want 4, 3 and 4, 4, 3 and 4, and minus OA is already provided, which is 1, 2 and 1, so 1, 2 and 1. Similarly we can find this BD as well. BD will be OD, which is given, which is 3, 0 and 2, 3, 0 and 2, and minus OB is also provided, which is 2, 5 and 3. So these are the values which are given in the question from where we are taking. Now this one, AC will be equal to 4 minus 1, I can write here to save space. So this will be 4 minus 1 will be 3, and 3 minus 2 will be 1, and 4 minus 1 will be 3. So 3, 1, 3 will be for AC, and for BD we can write here 3 minus 2 will be 1, 0 minus 5 will be minus 5, and 2 minus 3 will be minus 1. So this will be basically BD, 1, minus 5 and minus 1. Now we can find AC dot BD. So dot product of these two vectors should be equal to 0. To find dot product, we will take AC, which is 3, 1, 3, and then we will take 1, 1 minus 5 and minus 1, and dot product we will be writing this into this will be basically 3, this into this will be minus 5, and this into this will be minus 3, which is equal to, this will be cancelled, and minus 5, which is not equal to 0. So this proves that A, C and BD are dot product is not equal to 0. So they are not perpendicular. So we can write that they are not A, B and A, C and B, D, B, D are not perpendicular. So in case of rhombus, they should be perpendicular, right? So not a rhombus, so we can write here, hence not a rhombus. So this will be done. Now B part, find angle BAD, giving your answer in degrees. So from the diagram we can check BAD angle is basically BAD angle is this one. So this is between AB vector and AD vector. So we can write formula, basically formula which we will be using will be cos theta is equal to, and the two vectors are AB and AB and BD, basically AB and it will be AB and AD, sorry, AB and AD. So we will write AB dot AD, and this will be vectors, basically not mod. So this will be this vector dot product of these two and divided by their mod. So AB vector dot AD vector, this will be the formula which we will be using. Now we need dot product of these two and mod of these two, and we will check the basically theta we can check from there. So to calculate this one, we can find AB. So AB vector is equal to OB minus basically AB will be equal to OB, which is 2, 5 and 3, and minus OA, which is 1, 2 and 1. So this will be equal to 2 minus 1 will be 1, 5 minus 2 will be 3, and 3 minus 1 will be 2. So 1, 3 and 2, this will be AB vector, and AB mod we can find from here, which is equal to x square plus y square plus z square. So 1 square plus 3 square plus 2 square under root, this will be the value, and this is equal to 1 plus 9 plus 4, so 14 under root, this will be AB mod. And similarly now we can find AD mod as well. AD vector first we will find, and AD vector is basically OD minus OA, and OD minus OA we can find from OD we have like 3, 0 and 2, and A is minus 1, 2 and 1. So this will be AD, and this will be equal to 3 minus 1 will be 2, and 0 minus 2 will be minus 2, and 2 minus 1 will be 1. So 2 minus 2 and 1, and AD vector mod we can calculate. So this is equal to 2 squared and plus minus 2 squared plus 1 squared and under root, and this will be equal to 2 squared will be 4, and this will be 4, 4 plus 4 8 plus 1 9. So this will be 9 under root. So we can write this one as 9 under root, which will be equal to 3. Now we got AB mod and AD mod. So two values we got. Now we have to take the dot product of AB and AB vector and AD vector. Dot product of these two vectors we can write AB, which is 1, 3 and 2, and dot product with AD, which is 2 minus 1 and 1. So we have taken this one and this one, 2 minus 2 and 1, and we will be writing the dot product of these two vectors, which we can mention, like for example 1 into 2 will be 2, and 3 into minus 2 will be minus 6, and 2 into 1 will be plus 2. So this will be 4 and this will be minus 2 basically. So we got all these values. So now we can write cos theta is equal to AB dot, okay, so this is minus 2 value for this one, dot product, and divided by this one 14 root and 3, so multiply by 3 this one. And now we can take cos inverse to check for the value. This implies theta is equal to cos inverse of minus 2 over 3 under root 14. And if we check with the calculator, so inverse cos of minus 2 over 3 root of 14, and this will be equal to 100.26. so this is equal to 100.26 degrees, and approximately we can write this is equal to 100.3 degrees. This will be our final answer for this one. Now they are saying find the area of the parallelogram correct to 3 significant figures. So area we need to find for the parallelogram. So for area of the parallelogram we will be considering the same drawing, which is this one. So area of this A, B and D triangle, basically if we find the area of this one, we have this angle which is 100.3, which we have calculated 100.3 degrees. We have this angle. Now we can find half into AB into AD, and we will double that one. So we will write area of this will be equal to 2 times area of 1/2 of triangle will be AB into AD. So AB sine theta, so sine will be 100.3 degrees. So we will calculate this one. This 2 will be cancelled with this 2, and AB and AD we already have basically calculated, and we have this value AB mod we have calculated in the previous section, which is 14 under root. So we will write here 14 under root, and AD is 3, so it will be into 3, and sine of 100.3 degrees. And this one we can calculate, basically this will be root of 14 and multiply by 3 into sine of 100.3, and this will be equal to 11 basically this will be 044. So this is equal to 11.044, and approximately we can write this as 11.0, and because there are no units mentioned, so you will write as units. That's all, because centimeters are not provided, centimeters or meter or whatever units, so we will just write units. Now this is question number 9. The complex number u and w are such that this is equal to 2 iota and uw is equal to 6. Find u and w, giving your answer in the form x plus iota y and xy are the, where xy are the real and exact numbers. So this basically u minus w is equal to 2 iota, this is given, and this second equation is this one, which is we can shift basically w to the other side, and u will be equal to w plus 2 iota, and this is u w is equal to 6. This is also provided. Now we can replace the value of u in this one. We will substitute the value, and w plus 2 iota and into w will be equal to 6. We will get quadratic equation, and if we write quadratic equation will be w squared and plus 2 iota w is equal to 6, or we can write minus 6 is equal to 0. Now this is basically value of a we can write as 1, and b it will be equal to 2 iota, and c will be equal to minus 6, and we can write the basically we can write the quadratic equation. W will be equal to minus B means minus 2 iota and plus minus B square minus 2 basically 2 iota squared, B square minus 4 into A which is 1 into C which is minus 6 over 2A, so 2A will be 2 into 1. This will be basically the quadratic equation, and we can simplify this as this will be minus 2 iota, so this will be equal to minus 2 iota plus minus this will be iota square will be minus 1, so this will be minus 4, this will be minus 4 and minus minus this one plus, so 24 over 2. This will be after further simplification we can write it as minus 2 iota and under root will be 20 over 2. Basically this will be plus minus, we missed over here, and this will be our value, and we can further write it as minus 2 iota plus minus this will be 4 into 5, and 4 will be going out as 2 under root 5 and divided by 2. Now we can basically cancel this 2 also, and we will get the value as so after, like, we can take 2 common from here, inside will be minus iota plus minus under root 5 divided by 2, and this 2 will be cancelled with this one, and we will get minus iota plus minus under root 5. This will be W1 and 2, basically both values we have written over here. Now these are basically 2 values which we can use and find this one, find the this value. So these values basically we will be inserting in this U value. U is equal to minus iota. We can write U is equal to this W value will be minus iota and plus minus under root 5 this one and plus 2 iota, and this will be, if we will take plus value, this will be U is equal to minus iota plus under root 5 and plus 2 iota this one, and if we take minus value, so it will be equal to minus iota minus under root 5 and plus 2 iota, and this one can be further simplified as iota plus under root 5, and this will be the other one will be, you can move page, so this will be equal to minus under root 5 plus iota. So these will be basically the 2 values of U which we got from here. So this question is basically done. Now we can move to this question B part. On a sketch of an organ diagram, shade the region whose points represent complex number z satisfying the inequalities, this one and for this range, and this one we have to represent this. So to sketch this curve, basically graph, so what we'll be doing, we'll be just taking the coordinate axis, like for example this one, and this will be the real side, and we can write this one as real side, and this will be imaginary side. And now this is basically origin, and from this equation we can understand that we can check y, x over y value. So this is basically z minus, and we can rewrite this one as 2 plus 2 iota, and this is imaginary part and this is the real part. So in this one we can basically, if we complete, this will be less than equal to 2, and tan theta will be equal to 2 over 2 y over x, so this will be 2 over 2 which is equal to 1. So tan inverse theta will be equal to tan inverse, so theta will be equal to tan inverse of 1. So we can write here tan inverse of 1. So tan inverse of 1, we can check inverse tan of 1. This will be radians. This will be pi by 4. So value of theta is pi by 4 for us. So for this one, it should be less than equal to 2, and we can basically, real part is x value, which is 2. So we'll be taking 2 units on this side. So this is just a rough drawing. I'm just to draw this one for to show a clear and neat working to you, so that you can understand better. And this side will be 2 units, this one. So 2 cross 2 we can mark over here. This will be like 2 cross 2. So this will be the 2 and 2, 2 units this side and 2 units this side, real part and imaginary part. And it will be a circle, like for example, if so we can draw a circle with this one, and it should be circle like this one. You can draw a rough circle, but I just want to explain this basically. So this is basically done. Now after this one, this is the circle which we have taken from this equation, and now we'll have to take this one, like for example, argument of z is equal to pi by 4. So pi by 4 is passing through origin, and it will be 45 degrees. So 45 degree we can draw like this one. Pi by 4 will be like this. So this will be taken from this one, and the real part of z is equal to is less than equal to 3. So this is 2 units. If we take 3 units, and basically 3 units, if we take this one, 3 units will be up to this one. So we can draw 3 unit like this will be like this one. So it will be perpendicular line from here. So we have to draw we have to shade the portion which is less than this one, less than 3 and this, and within this circle, and lower than this line. So within this circle we will be shading this part, and this will be the shaded part which is required for this. This is basically rough drawing which we have drawn for this. So this is what we are done with this part. Now next question, we can move to the next question, which is question number 10. A tank contains water. A tank containing water is the form of hemisphere. The axis is vertical. The lowest point is A. This is the lowest point, and the radius is R. Radius is R as shown in the diagram. The depth of the water at time t is h. At time t is equal to 0. The tank is full, and the depth of the water is R. And at this instant, a tap at A is open. So tap is opened, and the water begins to flow out at the rate of this one. The tank becomes empty at t is equal to 14. The volume of water in the tank is V, and the depth is h. It is given by that V is equal to this one. Volume of this is equal to this. So show that h is and t satisfy the differential equation of the form this one, where b is a positive constant. Now we know that the flow is decreasing, and this volume is decreasing basically, and at a rate of this one under root h. So we can write change in volume with respect to time is proportional to this one decreasing by this, and we can change the proportionality into equality. So dv over dt is equal to minus k. K is constant of proportionality into under root h. Now we have to basically find the dv. Dh over dt is required. So for dh over dt, we can write it as dh over dv into dv over dt, and v is given, so we can find dv over dh and we can replace over here. Our v value is basically v is equal to 1 by 3 pi into 3r h square minus h cube. This is basically v value. We can multiply this and we will be getting pi r h squared and minus 1 by 3 h cube. And now we can differentiate it with respect to h. If we take dv over dh, this will be equal to derivative of this one with respect to h will be 2 pi r into h minus derivative of this one will be 3 into h square, so 3 will be cancelled, and basically we have to multiply this also with pi, so we'll write here pi. So this will be pi h squared because 3 will be cancelled with this. Now we can write it basically we can invert this one because we need dh over dv. We don't need dv over dh. dh over dv is required, so I'll move the page a little above for clarity. This one. Okay, so dh over dv will be reciprocal of this one, so reciprocal will be 1 over 2 pi r h minus pi h squared. This will be value for this one. Now we can write for dh by dt, and dh by dt will be equal to so this will be equal to, we can write dh by dv into dv over dt. This will be resulting to dh by dt, and these values dh by dv we have calculated over here. We can write here 2 pi r h minus pi h squared into dv over dt we have calculated over here, and we can write here minus k into h under root or h raised to the power 1 by 2. So this will be our equation, which we can further simplify as basically we can cancel. We can take h common from here. Basically h raised to power 1 by 2 we have to cancel, so we can take minus k and h raised to the power 1 by 2 over, this will be we can take h by 2, h raised to 1 by 2 common from here, and this will be 2 pi r h h raised to 1 by 2, and plus this will be pi h, not plus, this is minus basically. So this will be minus pi and h raised to the power 3 by 2, and this we can cancel with this, and our final answer will be minus k over this will be 2 pi r h raised to the power 1 by 2 minus pi h raised to the power 3 by 2, which is basically this one, the required answer. Hopefully you understood this well. So next thing, the only thing is this b part, b, which we can write it as, if we compare, this one is 2 r is there, pi basically we have to take common. So if we just write another step like minus k over pi, and inside will be 2r h raised to 1 by 2 minus h raised to 3 by 2, and this portion we can write as b, k over pi is equal to b, so this will be minus b over 2r h raised to 1 by 2 minus h raised to 3 by 2, where we can write b is equal to k over pi. This will be here. So this is basically done. Now this is b part. Solve the differential equation and obtain an expression for t in terms of h and r. So to solve the differential equation which we got in the previous part was this one, dh over dt is equal to minus b over this. So I will copy over here. So dh over dt is equal to minus b over, this will be 2r h raised to the power h raised to the power 1 by 2 minus h raised to the power 3 by 2. This is our differential equation. Now we will be cross multiplying. This side we will take to this side, dh side. So this will be 2r h raised to the power 1 by 2 minus h raised to the power 3 by 2, and this will be dh, this one, and this will be equal to minus b, because this is minus, so minus b integral dt, constant will be outside. Then we can just take integral of this one. So integral of this will be 2r raised to the power h raised to the power 1 by 2 plus 1 will be 3 by 2, basically h raised to the power 3 over 2 over 3 by 2. This will be the integral, and minus h raised to the power 3 by 2 plus 1 will be 5 by 2 divided by 5 by 2, and this will be equal to minus b, and this will be t, so minus b t. Now we have to basically find the values of constant. We'll add constant over here, and this c value we have to calculate. So before finding the c value, we will be just simplifying this one. So this will go up, so it will be 4 r h raised to power 3 by 2 and over 3, so we'll write 4 by 3 minus this will be 2 by 5, so 2 over 5 h raised to power 5 by 2, and we can shift this to this side, so minus bt, basically plus bt is equal to c. This will be the value. And now we can replace this basically at t is equal to 0. They are telling us that at t is equal to 0, this h value is equal to r. So we will write here at t is equal to 0, h is equal to r, and we will replace here. So it will become 4 by 3 r into r raised to power 3 by 2 minus 2 over 5 r raised to the power 5 by 2, and plus t is equal to 0, so this will be 0 is equal to c. This will be basically the c value which we can utilize. So if we simplify, this will be 4 by 3 r raised to power 3 by 2 plus 1 will be 5 by 2 minus 2 over 5 r raised to power 5 by 2 is equal to c value. Now we can simplify these two. 4 by 3 minus 2 by 5, 4 over 3 minus basically minus 2 over 5, and this will be resulting to 14 over 5. So c value we can write as 14 over 15, basically 14 over 15 r raised to the power 5 by 2, and this value we will be replacing in this equation, and we can write it as 4 over 3. I will move page so that you can see properly. So here this will be 4 by 3 I'm replacing in this one 4 by 3 r and h raised to the power 3 by 2 minus 2 over 5 h raised to the power 5 by 2, and this will be equal to we can shift this to the other side, or we can keep on this side also, so minus bt and plus this value which is 14 over 15 r raised to the power 5 by 2. This will be basically the substitution, and now we can find the value of bt. We will send bt to this side and send this to other side, and this will be equal to 14 over 15 r raised to the power 5 by 2, and plus this will be this one we will shift to the other side, so it will become plus 2 by 5 h raised to power 5 by 2, and this one will be minus 4 by 3 r raised to the r h raised to power 3 by 2. So now we can further simplify. Basically we need the constant value for b also, and we know it's given in the question that at t is this one when this will be finishing and t value will be 14. So at t is equal to 14, height will be 0. So h is equal to 0 at t is equal to 14, and at t is equal to 0 h is equal to r. These are basically the two constant values which we are using for evaluation of constant. So now t is equal to 14 when h is equal to 0. So h is in this one, h is in this one, so these two factors will be 0, and this will become 14b. So 14b is equal to 14 over 15 r raised to the power 5 by 2. We can shift 14 to other side, so it will be b is equal to we can cancel basically this one, so this will be 1 over 15 r raised to power 5 by 2. This will be the value of b, which we will be replacing in this one. Basically we got this c value we replaced over here, so in this one we can replace this value. So basically this is the step in which we have replaced the value of c. Now this b value we will be replacing here, and we can rewrite this step as 4 by 3 r h raised to power 3 by 2 minus 2 over 5 h raised to power 5 by 2, and this is equal to minus this b value 1 over 15 r raised to power 5 by 2 t, and plus this will be 14 over 15 r raised to the power 5 by 2. Now we will go to the next page, and what we will be doing now, we have to basically find the t value, and t value is this one, so we'll make t as subject, this is negative, so we will shift this to other side, and these things we will be shifting to the other side of the equality. So on additional page I will be copying this one, so this one I'm writing to the other side like 1 over 5 r raised to the power 5 by 2t is equal to rest of everything I'm writing on the other side, which is first one is this one 14 over 15 r raised to the power 5 by 2, and the two other terms which are plus 2 by 5 h raised to the power 5 by 2 and minus 4 by 3 r h raised to the power 3 by 2. So now this is done. These two terms we have shifted to this side, and this term we have shifted to this one t term we have shifted to other side. Now further simplification, basically our target is to find t value, so we'll be shifting everything to the other side, and this one basically if we check this is t value is 1 over 15, so we have written here 1 over 5, so I'll change to 15. Now this is done. Now we will be shifting 15 to other side, so r 5 by 2 t will be equal to 15 into this, so 15 will be cancelled, and this will be 14 r raised to 5 by 2, and plus this one 15 into this will be 3 into 2 will be 6 h raised to the power 5 by 2, and minus 15 into 3 will be 5, so 20 r h raised to the power 3 by 2. This will be basically our equation. Now we'll be shifting r raised to power 5, so t will be equal to 14 r raised to power 5 by 2 over r raised to the power 5 by 2, and plus 6h raised to the power 5 by 2 over r raised to the power 5 by 2 and minus 20r h raised to the power 3 by 2 over r raised to the power 5 by 2. We can divide this. Now the final equation t will be equal to, this will be cancelled, so it will be 14 plus this one we can write 6 and h raised to the power 5 by 2 and over r raised to a 5 by 2, so we can write combined power as this one, and minus this will be 20 and h raised to the power 3 by 2, and if we shift this one, 5 by 2 minus 1 will be 3 by 2, so over r raised to the power 3 by 2, so we'll write in common brackets. So this will be basically our final answer to this question. We are done with the paper. Hopefully you understood each and everything. I'll be waiting for your comments. Recommend this channel to your class fellows and other students. Also introduce this channel to your respected teachers, and don't forget to subscribe Maths TV. Thank you very much for watching. Take care. Bye.